Hi class. This is the fourth transformation that we'll be looking at, and it's called enlargement. Despite its name, we can use this to make shapes bigger or smaller, right? The whole point of enlargement, as I said, is we want to make shapes bigger or smaller by a certain factor, so we can describe exactly how big or small we want to make it compared to the original shape, and we're not changing anything else about the shape. So you'll get to see that here. The orientation and the shape itself will stay exactly the same. So how do we do enlargement? So again, if we find on the transformation, we can find dilate from point. This is the name that GeoGebra uses. It's called dilate from point. If we click on this, we can see select object, select the center point, then select a factor. Okay, so the first step is we're going to need a point to dilate or enlarge from. So let's make a point around here. So I've got point E, so I want to enlarge this shape using point E. Let's see how this works. So I go dilate by point, click on the shape, click on the point, and then says, hey, how much do you want to enlarge by? So if your shape is a 1, how much bigger do you want to make it? So if I click on a 2, it should make my shape twice as big. So if we click OK, you can now see how this works. It's now twice as big, and it's moved away from the point E. So how does this work? If I create a vector, just kind of highlight this. What the computer does is it starts with point E, and then it finds your corner A, and sees, oh, this vector took me 3 spaces to get to A. So, and because you want to double it, what I now want is from point E, I'm gonna have to go twice as fast, so that's 6 spaces, and this is how we set up the first point. And let's do it again with, say, point D. So I want to get to point D, which took me a vector of 3 spaces down and 1 space across. So if I want to enlarge this and by a factor of 2, I have to now go 6 spaces down and 2 across, and that now sets up the next point of my enlarged shape. So this is what it'll do. It'll go from wherever point you have and match the distance and double or multiply that distance by whatever factor we wanted, right? If we wanted to, of course, move the point, that would then widen the distance from the shape and go further across. All that does is change the position of the shape, but it doesn't actually change the size. So you can see no matter how I move it, the size of the shape stays exactly the same because that's determined by the factor. All that changes is where the shape ends up in. I can also have my point be one of the points directly. So maybe I want to enlarge directly from A, and all it'll do is create the larger shape where the point A of the original triangle stays exactly where it was before, but the rest of the shape just gets larger that way. Right. Let me reset things. Let's try the same thing, but this time we're gonna want to make it smaller. So for whatever reason, we want to make the shape smaller. So if I go dilate from point, click on the shape, click on the point. To make it half as big, I have to write 0.5. So 0.5 is half as big. If I were to write 1, just for information, that's exactly the same shape. So half of 1 is 0.5. This gives me a shape that's half as big. I click on OK, and you can now see that shape there is half as big as the original shape. Yep. So how do we describe transformations? Let me find the twice as big one, because that's the one. That's a nice one to just describe. So I want the shape that's twice as big. Yep. So how do we describe this transformation? Again, look at everything we needed. We need the shape, we needed the point to enlarge from, and the factor, how big we want to enlarge it. So when I go to describe the shape text, I might say I enlarged the what do we call that shape? The arrowhead by a factor of 2. So I've doubled the size from the point E, which was 10.7. Right. So I enlarged the arrowhead by a factor of 2 from point E. So we're describing the shape, the factor of enlargement, how much are we enlarged by, and where our center of enlargement is. So rather than saying point, we should probably say center or center point or something. That is the official name for how we do the enlargement, right? So enlarge the arrowhead by a factor of 2 from the center E, and I just gave the coordinates of that center. That would be a nice way to describe our shape, right? You could, instead of saying a factor of 2, if it's a nice number, you could just also say I doubled the size of arrowhead from the center E or something along those lines. But I think if we just keep it to factor, that'll be nice and simple, right? Why do we enlarge? So as you can see now, enlargement allows you to make the shape bigger or smaller while keeping the actual shape and proportions, right? So the arrow wasn't twisted, it wasn't like skinnier or anything along those lines. It was the exact same shape, just bigger, or the exact same shape, just smaller. What we do notice is that the position does change, but we can affect that, of course, by moving E somewhere. So if we want the exact same shape in the same like position where I wanted it to be before, we can just use its like point A, its own center, to make it as big, growing from there, if that makes sense. One last trick is we can also have a negative factor. So if I go dilate from a point, shape, point, and we type in -1, the negative just goes in the other direction. So if I just highlight that with the vectors, from A to here, it's 3 to the right. So therefore, if I put -1, it's going to go, 3 to the left. If I want to put -1, it's going to go 3 to the right. From E to D, it was 3 down and 1 to the left. So from E to the new D will be 3 up and 1 to the right. So that is how you can flip an object by doing an enlargement as well, if you'd like. Experiment, plan it out, make sure you know how to describe your transformation. It's really, really important. And I think that about covers it.